Hey everyone, so in the last video we discussed that when it comes to multiple files it becomes uh, a lot of effort to actually write those many commands to compile each file separately and then get our actual executable. So what we want to do is we want to give just one command which will compile all my files and give me the executable program. And if you've done shell scripting before, which we actually did at the start of this course as well, you might think that you could just write a shell script to do that, and that's perfectly valid. You could write a shell script with all of the GCC commands, and the last one should give you the executable file itself. So if you're on Linux, it'll give you a .out file. If you're on Windows, it would give you a .exe file. So that is perfectly valid, but we look at another way to do it here, and after we look at this method, we'll discuss why this method is better than using a shell script. So what we want to do is we want to create a file called, let's save this as Makefile, and this name is actually important, just name it as Makefile. And here what we can do is we give first a target. So my target, the target file that I'm looking to get is main.exe. In case you're using Linux, it will be make.out, main.out. And what does my main.exe depend on? It depends on all of my object files, and it depends on main.c. So here is my dependency. So this is my target, and these are the files that it depends on. So I just give space separated files. So it depends on mathfunctions.o, and now I can give a command. Remember, this indent is important. It should be one tab space and then the command which is actually used to create the main.exe file, which is gcc main.c mathfunctions.o, and the output should be main.exe. So once again, this is called the target. These are the dependencies, and this is the recipe. It's called the recipe. It's the actual command, and you could have multiple commands as well. So I could give another command here, but I don't want to do that because one command is enough for me. Now what I want to do is I want to say that this math functions file itself, so my math functions.o file, that itself depends on math functions.c, and I think that's all it depends on. And here my command would be gcc-c math functions.c, and my output should be math functions.o. So these are the two commands that I need to actually get my main.exe. And what I can do is I can write different ones here. So let's say I had, let's say, a module.o, and that depended on module.c. I could give a command for that as well. And remember that dependencies could also contain header files. So if I made a change to a header file, that should also be included here. So if you want some command to be run again based on some header file, I could give, let's say, mathfunctions.h as well here. So even if I change mathfunctions.h file, it will do this command again. So one other thing that I can do is I can say %.o depends on %.c, and then I can just write gcc -c, and the way to actually refer to that file is by doing a $@. So gcc-c $@ c -o $@.o. So I can give a rule this way as well, and that would generalize it for all object files being created from all .c files. So I don't really need this here. So once again, this one is my creates executable, or my binary. So that would be a .exe or .o. And what I can do now is I can go to my command prompt and I can just say make, and it says that main.exe is up to date. So let's just try changing some stuff. I'll go here and change this to 5 and 4, something like that. Even the smallest of changes fine. So now as you can see, it did gcc main.c mathfunctions.o -o mathfunctions main.exe. So it created my executable again, and I can run that executable now. So here is the advantage of a makefile over a bash script. Since we have just seen this command, it would make sense to you now. So when I ran this makefile, it didn't compile my mathfunctions.c file again. It just compiled my, it just used these two and created my main.exe. And the reason is because makefiles always do minimum rebuilds. So it actually checks whether files have changed, and only if the files have changed is it going to recompile those files. It's not going to unnecessarily recompile files that have not changed. So that's the biggest advantage that Makefiles give us over shell scripts. So it's actually for medium-sized projects or larger projects, it's actually better to have a Makefile and just write your appropriate rules there. So that's the general idea behind Makefiles. Of course, you could have done the same thing using bash script. You could have done minimum rebuilds using bash script as well, but that would involve a lot of checking the last modified date and stuff like that. Makefiles make it very easy for us. And another thing that I can do here is I can write a clean rule, and this doesn't have any dependencies for me. And here what I just do is I do a remove and force the remove. -f is the first flag, and I want to get rid of all my .o files, so mathfunctions.o and main.exe. So these are the only object files and binaries that I have. But a better way to do this would have been just to write star.o and star.exe. So it just gets rid of all of my binaries and object files. And let's go back here and do a make clean. So if I want to call this clean rule, I just have to write the name of the rule here. I say make clean, and it actually runs this command and it got rid of all the files. Now if I do a make again, as you can see, this time it it compiled the math functions file again, and then it created my main.exe. That was because it didn't find a mathfunctions.o file. So what it tried to do was it tried to create my main.exe, but then it saw that alright, there's a dependency here which is a .o file, and this doesn't seem to exist. So let me just check if any of my rules have a .o file as the target. So it got this one. So it said, alright, let's take a look at the dependency. I do have mathfunctions.c, so I'll run this recipe right here to get mathfunctions.o. And now coming back to my main.exe, now I have all of my dependencies, so I'm going to run this command. So this time it actually ran both of the commands because it needed to, but if I do a make again, it says main.exe is up to date, so it just says I don't need to do anything. And similarly, we can have a run command here, so I can write run and then I can do a /make. If you're using Linux, it would be make.out. In my case, it would be make.exe. Main.exe. And I can go ahead and do a make here. It says main.exe is up to date, and I can do a make run now, which runs the main file and gives me 4 as the output. But I just prefer running the executable myself, so I'm not going to be doing this. And that's the basics of Makefiles, and this concludes our discussion on modularizing our code as well. So I'll see you some other time.